Hi class, today we are on Saxon Math Book 4, Lesson 79, and today we're going to talk about symmetry. So I know that this is not the first time you have heard this word, symmetry. We're going to look at what it is and then a little bit about how they make 4th grade symmetry different from 3rd grade symmetry, or they just add a little bit more to the concept. So for starters, we find symmetry in nature, for example, in a butterfly, where you can kind of split the butterfly down the middle and say, hey, this side is exactly like this side, and if I fold them over, they're going to line up and they're going to match. So we call that reflective symmetry or just symmetry. So here's what you need to know as a 4th grader. Anything that has symmetry has what is called a line of symmetry. So in my butterfly here, if I split the butterfly right down the middle, that imaginary line is called my line of symmetry. So for our first example, they want to know which of these 4 figures does not have a line of symmetry. So in order to figure out which one does not, we're going to draw the lines of symmetry that do exist here. So let's start with the rectangle. I can do a line of symmetry straight down the middle like that, or I can do one horizontally across the middle. So this rectangle has 2 lines of symmetry. My triangle, does it have a line of symmetry? It goes straight down the middle there. This quadrilateral, that's kind of a funny looking shape. Does it have a line of symmetry? Is there a place where I could fold it in half and the 2 halves would line up? No. So this one is actually the correct answer for the question, which says which shape does not have a line of symmetry. Let's take a look at the square because it's a little bit different. We can do a line of symmetry like that, vertical up and down. We can do one horizontal. And because this is a square, I could also do diagonal lines of symmetry here, where I could fold them diagonally and it would line up perfectly. So the square has a lot of lines of symmetry. Okay, the next example shows you the word chair in all capital letters. So we're going to do C-H-A. The I doesn't have it in your book. It doesn't have that little top and bottom piece, so we'll just leave it like this. And R. And then the question says, copy these letters and draw each line of symmetry. So I'm going to have you copy them right now. Hit pause if you need another minute or 2. And then we are going to find the lines of symmetry. So in the first one, if I split my C vertically, would I be able to fold it and have the 2 halves line up with each other? Not vertically. Horizontally I can. So we're going to draw a line of symmetry right there, right in the middle, because if I folded that top piece down on the bottom piece, it would line up. What about the H? Where could I fold that? I could do it vertically down the middle. Could I do it horizontally? Yes, as long as I was right on this cross piece right there. We could fold it like that and it would fold down on top of itself. What about the A? How many lines of symmetry are there in an A? Just down the middle. Excuse me. And what about the I? How many lines of symmetry are there? Can I go vertically down the middle? I can, as long as I'm right on my eye. What about horizontal? Yes, I can fold that one over on top of itself as well. So 2 lines of symmetry for the eye. What about the R? Can I make a line of symmetry here? No. Can I make a line of symmetry there? No. So R is an example of a letter that does not have a line of symmetry. It is not symmetrical. Okay. So the other type of symmetry that we have is called rotational symmetry. And what that means is I can take a figure and I can turn it so that it lines up with itself. So for example, we'll start with this. If I turn this, if I turn it the whole way around, so here was my top, I'm going to keep my finger on the top so you can follow that, right? If I turn it the whole way around, keeping my finger on the top, any figure that I have, if I make a 360-degree turn, it's going to line up with itself because we went back to the starting position. But now, keeping my finger on the top, here's the starting position, straight up and down. Can I turn this less than a full circle and have it line up with itself again? Yes. We went from here to here. So we say that this figure has rotational symmetry because I can rotate it and it looks exactly like it did, in this case, 180 degrees ago. I turned it a half circle, which is 180 degrees, and it is in the same position. I could start it here and do the same thing where I turn it a half circle and it would line up with its starting position. So this has rotational symmetry. Think about the letter C. If I turn my letter C here, will it line up with itself? So we're going to imagine that I've turned it, and I'm just going to draw it. Here I'm turning it 90 degrees. That's not the same as the starting position. Here I've turned it 180 degrees. That's not the same as the starting position. Here I've turned it 270 degrees, not the same. So if I do another quarter turn, it'll be back, but that's a full circle. So we would say a C does not have rotational symmetry because as I turn it, it doesn't line up with itself until we get it the whole way around the circle. Let's do the same thing with the H. If I turn it a quarter turn, it looks like that. But if I turn it a half turn, 180 degrees, it looks like that, which is exactly how it started. So an H does have rotational symmetry. That rotational symmetry is if I turn it, will it line up with itself? Will it get back to its starting point before I have made the full circle? So our example for this one is, what about an equilateral triangle? So equilateral means each of these 3 sides are exactly the same length. Does an equilateral triangle have rotational symmetry? If I turn it so that this point is over here, will it look different or the same? I'm going to take this point and put it right here. And it looks exactly the same. So an equilateral triangle has rotational symmetry. What about an isosceles triangle, where 2 sides are the same length and 1 side isn't? If I take this point and move it down here, will it still look the same? No. So the isosceles triangle does not have rotational symmetry. What about a rectangle? Does a rectangle have rotational symmetry? If I only turn it a quarter turn, it'll look like that. But what if I turn it a full half turn? It should go back where my top side here is the bottom side there, and it looks the same. A rectangle has rotational symmetry. Okay, I have one more shape for you. What about a hexagon? A hexagon has 3 sides. So 1, 2, 3, 4, 5, 6. Although I kind of want them to line up. So more like that, okay? It's supposed to be a regular hexagon, which means each of its 6 sides are the same length. So if I turn this, let's say I turn it a quarter turn, I end up with that. But if I turn it a full half turn, I end up with that again. So a hexagon does have rotational symmetry. So that's the new stuff with symmetry. You have reflectional symmetry or reflection symmetry where the 2 sides fold on top of each other. And then you have rotational symmetry where if we rotate a shape or an object, it lines up with itself in the starting position. Boys and girls, your lesson practice today needs to be drawn. For those of you that are in my class, I expect you to have those drawings complete so that I can see them when we get together for class later this afternoon. If you are not in my class, please have a parent or homeschool teacher check over your work to make sure that you understand symmetry. The lesson practice begins on page 505, and when you finish that, your written practice homework begins on page 505 as well. I hope you have a great day, and I'll see you soon.